Hola, Cal. So, if you watched Integration by Parts video 1, example 5, we talked about having to do the parts method twice. Perhaps there would be an easier way, and there is, and it's called the tabular method. So, there is one stipulation for the tabular method, and it's the idea that if one of your parts has a finite number of derivatives, finite number of, and let's be more specific, non-zero derivatives. You can use the tabular method. And let's redo example 5 from the video number 1, and we can show you how that goes. And again, that was the integral of x squared sine 3x dx. Okay, so what you want to look at is we have our two parts. We're looking at x squared sine 3x. Which part has a finite number of derivatives? Well, that would be x squared, so I want to make that u. And that means that dv will be sine 3x. So I have x squared sine 3x over here. And of course, this guy's going to have the dx attached to it because we're going to take the antiderivative for dv. Now, let's go all the way down and take our derivatives in the u. Derivative of x squared, 2x. Go again, and go again, all the way until you get to 0. You have to get to 0, okay? Now, under dv, we're going to take the antiderivative. So we have negative 1/3 cosine 3x. Then that's negative 1/9 sine 3x. And positive 1/27 sine 3x. Okay, so I went ahead and I multiplied all the 1/3 times with our du, okay, if you had to do a u sub for the 3x, so that's where the negative 1/3, negative 1/9, and 1/27 are coming from. Okay, now, what you need to do is we're going to match them up diagonally, like so, okay? The initial dv is never used, and the 0 is never used. Okay, so you match them up diagonally. Then you're always going to start, your initial u was positive, and then you're going to alternate signs. So once we do that, we have our answer. So I have x squared, which actually I should probably put the negative 1/3 in front. Here we go. Negative 1/3 x squared cosine 3x. Then I have a minus 2x and a minus 1/9. So that's going to become actually a positive. I'll make that 2/9 x sine 3x. A positive 2 and a positive 1/27 is going to be a positive 2/27 sine 3x. And the last thing you have to add is your constant of integration. So there's your answer there. So again, that was example 5 from the integration parts video number 1, done again using the tabular method. So let's go again. Example 2. Let's do the integral of x to the 3rd e to the x dx. Okay, again, you need to pick a u and you need to pick a dv. Which one's going to give us our finite number of derivatives? You should be saying x to the 3rd. Then over here we're going to have e to the x. This problem is going to be super easy because, okay, x to the 3rd, take the derivative. 3x squared. 6x, 6, 0. Jump over to dv. dv is e to the x dx. What's the antiderivative of e to the x? That's so nice and friendly. Miss Gutierrez, can we have like 12 of these on the quiz? No. Okay, so again, match it up diagonally. 1, 2, 3, and 4. Start with a positive sign, alternate, and write your final answer. So I have x to the third, e to the x, minus 3x squared, e to the x, plus 6x, e to the x, minus 6e to the x. And what do we have to add? Plus our constant. Okay, so hopefully you're falling in love with the tabular method because it's very quick and easy and we like it. So I'm going to give you example 3 as a you do. Okay, you try it. Let's go with the integral of x squared cosine 2x dx. So pause the video, try this one as a you do, and then come back and let's see how it goes. All right, so what should you be? X squared. Good job. Okay. You can only entertain yourself so much, guys, talking to a screen. And dv is cosine 2x. Derivatives going down. 2 and 0. Okay? Antiderivative. 1/2 sine 2x. And then, again, you'll have another 1/2 with the 1/2, so that makes it 1/4, but it's a negative cosine 2x. Bringing back in, and then we have another negative 1/8 sine 2x. Matching up diagonally, alternating signs. Your final answer should be 1/2 x squared sine 2x plus 1/2, because the 2 and the 1/4, x cosine 2x, and then a minus 1/4 sine 2x. Add your constant, call it a day. Hope you did good. Okay? So, some problems you could do to practice the tabular method would be on page 346. Numbers 4, 21, 24, 25, 30, 33, 39, and 40. Okay? Those will all be good practice for the tabular method. Hope you guys are having a great day, and I'll talk to you soon. Bye.